work done by constant force. Work done by constant force. By constant force. And we have already defined that work done by constant force W is equal to nothing but F dot S. F dot S, dot product of force and displacement. Okay, we have already defined work done and it is scalar quantity. So you can write this F dot S as obviously that W is equal to Fs cos theta. So this W is nothing but Fs cos theta. Fs cos theta. Okay. Now there is various possibility that when W is 0, that is when workless force. Okay, when W is positive and W is negative. So there is three possible case. So according to the value of theta, okay. So when theta is equal to, I have discussed earlier that when theta is equal to 90 degree, that is pi by 2, so W is equal to 0. So if the force is perpendicular to the displacement, in that case W is equal to 0. Okay. Similarly, if theta is, and theta can vary from, I have discussed earlier that theta can vary from 0 to 180. Suppose this is our S, displacement, direction of displacement, and this is F, and the angle between F and S is theta. So F can vary from 0 to 180. Okay, from 0 to 180. When force is acting opposite to displacement, then it will be 180 degree. So theta can vary from 0 to 180 degree. Okay, 0 to 180 degree. But within this range, if theta is greater than 90 degree, theta is greater than 90 degree, so in that case cos theta is negative. So in that case cos theta is negative. So when cos theta is negative, then obviously you can write that W is equal to negative. W is equal to, so work done is negative in that case. Similarly, if theta is less than 90 degree, if theta is less than 90 degree, then what will happen? Then cos theta will be positive. This is first quadrant, and cos theta will be positive. And when cos theta will be positive, then W will also be positive. Okay. So this is the positive work done, negative work done, and zero work done. So you should remember only that you should keep in mind the angle between F and S. Okay, so you already have to see the angle between F and S to conclude that work done is 0, negative or positive. You don't need to remember that work done on by force, work done against force, etc. You don't remember that kinds of situation, but only you have to understand about the angle between F and S. So if the angle between F and S is greater than 90 degree, then obviously W will be negative, and if it is less than 90 degree, then W will be positive. So this thing will be more clear to you if I take one example. Okay, so let me take one example so that you can understand how you can find out the work done. Okay, so let me take an example. Okay, so example 1. So I'm going to take this example here, and that is, suppose a block of mass, let me write down it. Okay, a block of mass m is equal to 2 kg, m is equal to 2 kg is pulled by a force, F is equal to 40 Newton, by a force F is equal to 40 Newton upwards through height, h is equal to 2 meter. Okay, through height h is equal to 2 meter. Find the work done on the block. Find the work done on the block. Find the work done on the block. Work done on the block by the applied force. By the applied force F and its weight mg. Okay, and you have to take g is equal to 10 meters per second square. Okay, so here in this example understand better that when work done is positive and when work done is negative. Okay, so here block of mass m is 2 kg. Suppose we have a block of mass m here 2 kg and force F is equal to 40 Newton. Force F is equal to 14 upwards through height 2 meters. So a force F is 40 Newton is applied, and by this force the object can be pulled up to height h, that is 2 meter h. Okay, and that is 2 meter, that is 2 meter. And here the work done by the force F, you have to find the work done on the block by the applied force F and its weight. Its weight mg will be downward direction. So when you talk about the work done by the force F, you can understand easily. So first you have to find out work done by the force F. Okay, work done by the force F. So you will have F is equal to F into S into cos 0 degree, because you have F and S in the same direction and S is H here. Okay, F and S is in the same direction, so you should write here F H cos 0, so that will be F into H only, and F is here 40 Newton and H is 2, so you will have 80 joule of work done. But you can find also that the work done by mg. Okay, so you can write it like this, Wmg. So you can denote it at Wf, that means work done by the force F and work done by the weight mg. But mg is here opposite to displacement. The displacement is along upward direction and mg is along downward direction. So angle between F and mg here is 180 degree. So you should have here mg, that is force into displacement, into cos 180, and cos 180 is minus 1, so you will have minus mgh, and that will be minus m2 g, you have to 10 and h is 2, so it will be minus 40 joule. Okay, so you can understand how work done is negative. Here force is exactly opposite to the displacement. Okay, so that means it is 180 degree, obviously it is greater than 90 degree, and this is the maximum value of theta. When force will be acting exactly opposite to the displacement. Okay, so this is how you can solve this kinds of problem also. Okay, now let me solve another problem which is directly based on dot product of F and S. Okay, sometimes these kinds of problems are also asked. So let me take one more problem. Okay, and here the problem is that a body is displaced from point A, which is 2 meter, 4 meter and minus 6 meter. Okay, minus 6 meter to RB, and RB is 6i minus 4j plus 2k meter under a constant force okay, F is equal to 2i plus 3j minus k Newton. Find the work done. So how you can find here? You can find work done by doing direct dot product. Okay, by doing direct dot product you can find. So we have W is equal to F dot S, and S is the displacement, that is difference between two position vector. So here it will be RB minus RA. Now RB is given in the vector form, but RA is in the coordinate form, so you have to transfer this coordinate form into vector form, and it will be 2i cap plus 4j cap. Sorry, first you have to write RB. Okay, First you have to write RB. Okay, RB is given 6 I cap minus 4 J cap plus 2 K cap. Okay, minus RA, and RA is here according to this coordinate you will have 2 I cap plus 4 J cap minus 6 K cap. So it will be 6 minus 2, that is obviously 4. So it will be 4 I cap minus 4 that is 8 J cap, and plus 2 plus 6 that is 8 K cap. So this will be displacement. This will be displacement vector S. Now work done will be what? F dot S. So W will be, A vector is given here, that 2 I cap plus 3 J cap minus K cap dot S vector is 4I minus 8J plus 8K. Now if you took dot product, then look 4 into 2 8, 3 into minus 8 that is 24, minus 24, and minus 1 into 8 that is minus 8. So this 8 will be cancelled out, it will be minus 24 joule. So work done will be here minus 24 joule. Okay, so sometimes questions are asked from this direct dot product also. Okay, now let me solve another important problem, then I will conclude this class. Okay, so next example 3. Then I will move to work done by variable force. Okay, after this example, so here the example is that two unequal masses of 1 kg and 2 kg are attached at the two ends of a light inextensible string passing over a smooth pulley as shown in figure. If the system is released, I will give you the figure. Let me write down first of all. If the system is released from rest, then find the work done by string on both the blocks in 1 second. Okay, and the diagram is given here. This is a frictionless and massless pulley. Two objects, one is 1 kg and another one is 2 kg, are attached like this. Okay, and you have to find out the system. You have to find the work done by the string on both the blocks in 1 second. Okay, so work done by the string. Work done by the string means work done by tensional force. Okay, work done by string means here work done by tensional force, because you know the tensional force will be T, and here also tensional force will be T. Now unequal masses are attached to ends, light is passing over a smooth pulley as shown in figure. System is released from rest. So you have to first find out in 1 second what will be the displacement of both these blocks. Okay, what will be the displacement on both these blocks, you have to find out first. So for that you have to know acceleration of this system, and you know for this mass pulley system in Newton's law I have discussed that here the acceleration will be what, m2 minus m1 divided by m2 plus m1 into g, and here m2 is 2 and m1 is 1, so it will be 2 minus 1 divided by 2 plus 1 into g, and that will be g by 3, and g you have to take 10 here, so it will be 10 by 3 meter per second square. This will be the acceleration of each and every block, and it is released from rest. So after time t, displacement should be, displacement s will be half at square, because initial velocity is 0, released from rest. So half into 10 by 3 into t square means 1 square, that will be 10 by 6, that means 5 by 3. So 5 by 3 meter is the displacement. So this 1 kg block will move upward and this 2 kg block will move downward. So it will have displacement in the direction of t for 1 kg block, but the displacement, the magnitude of displacement is same in each cases along this direction. So t and s will be in the same direction for 1 kg block, and t and s will be in different direction. Along this direction it will be s, but t will be along this direction. So here for 2 kg block, the direction of tensional force and the displacement will be opposite to each other, and here will be in the same direction. So for 1 kg block, so on 1 kg block, work done on 1 kg block if you talk, so work done by the string obviously, but on 1 kg block, so on 1 kg block if you denote it by W1, then it will be TS just, and T is what, you have to find out T also, and you know again from your Newton's law that T will be twice m1 m2 divided by m1 plus m2 into g. This will be your tension. Okay, so T will be 2 into 1 into 2 by 3 into 10, so it will be 440 by 3. So tensional force will be 40 by 3 Newton. Okay, so it will be 40 by 3 into displacement vector is magnitude of its 5 by 3, so it will be 200 by 9 joule. Okay, but for 2 kg block it will be what, Ts cos 180, so that will be minus Ts, but the magnitude will be same because it will be 40 by 3 into 5 by 3, and that will be obviously minus 200 by 9. Okay, so this is how you can solve these kinds of problems for constant force.